Okay, so welcome to the third and potentially the last tutorial on the review for the laws of motion test for the APIB physics class. So this next one, number 5, has a block of mass m being pulled along a horizontal frictionless surface by magnitude f. So I want to figure out the acceleration of the block. So I know a equals the f net over m. So you might want to think right off the bat that it just is f over m, but don't forget that this force is acting at an angle. And actually I'm going to draw my triangle up here. So what I want to figure out is that x component. Now you got to be careful that the angle is with respect to the vertical. So if I want to figure out this x component, that is across from the angle, so the x component is actually equal to the force times the sine of the angle. Okay, so just be mindful of where your angle is drawn from, and so that gets us f sine theta over m. All right, this next one, I put a little note here, just talking about my idea on it, but it definitely does test your understanding of the normal force and what the scale reads. So we know that she's accelerating vertically upward, so we do know that the upward force, which is r, the scale reading, has to be greater than the weight w, but it asks for what's the reading on the scale, and that is the upward force. So the answer is just r. Now I know r is got to be greater than w. Okay, so I do know that that is the case, but it's just asking for the reading on the scale, and that is just r. All right, the next one is a slightly complicated problem, actually, because when I first looked at this, you have to evaluate what's the difference between A and B. And if you look carefully, there is a difference. Okay, and let's just talk about this. So we have a tension that is going along the rope, and then we have a force of gravity going down, so the mg going down. So what I know is that that tension, Ty and Tx, that tension in the y balances out that force of gravity. And so that also means that the tension over the overall tension is got to be greater, so T is got to be greater than Ty, because the Pythagorean theorem says that the hypotenuse is the largest side. So to kind of whittle it down between A and B, B is the correct answer simply because this line is bigger than that line. And then the last one here is the net force acting on the body is 0, which the following must also be true. So Newton's second law is the sum of the forces equals ma, and if the net force is 0, then that means the left-hand side of this equation is 0, which means the right-hand side of this equation is 0. And it's not because the mass is 0, but it's because the acceleration is 0. And you do not have to have an object at rest in order to have an F net of 0. Consider an object moving at a constant velocity. All right, so these are actually some Regents questions, so maybe you find these slightly easier, maybe some of them are slightly more complicated, but nevertheless, let's go through them. And so Jim wishes to push a 100-Newton wood crate across the wood floor. What is the minimum horizontal force that required to do that? So the important thing is to start the crate from moving. And so to start the crate from moving, then you know that you need to use the static coefficient of friction. So if you look up the static coefficient of friction of wood on wood, you get 0.42, and then this is the force of gravity, which is equal to the normal force since it's not accelerating upward, it's not on a ramp. Vertically, it's not on a ramp, nor is it have an additional upward or downward force. So multiply the two together, multiply 0.42 times 100, you get 42 newtons worth of force. All right, the next one we're looking at, we know that there's some drag force as a result of the forces shown, the parachutist may be. So what I know is that the drag force acting on the parachute is equal in magnitude but opposite in direction. So what I know is that they're moving at a constant speed, okay, and actually gets rid of all of them but 2. And also, if I wanted to say, well, they're moving up or down, you can consider this, that the parachute wouldn't arrange itself like that if they were moving up. Number 3, we have a wooden block is at rest, a horizontal steel surface, 10 Newton force is applied parallel to the surface required to set the block in motion. How much force is required to keep the block moving at a constant velocity? Those of you that originally had 10 newtons, you're forgetting the fact that the kinetic coefficient of friction is less than the static coefficient of friction, meaning that once you get it moving, it's now a kinetic case. So the force, I don't know what the number is going to be, but I know it's going to be less than 10. All right. Number 4 here, in order to keep an object weighing 20 newtons moving at a horizontal speed, a 10 Newton force is required, the force of friction between the object. So it's constant speed, so the applied force equals the frictional force, so we get also a value of 10. All right. Number 5, we have weight versus mass, and we're asked to figure out the slope, what the slope represents. So we have f of g and m. So, what you could do is you could use your reference tables to say what is the value of, what is the quantity f of g over m equal to, and if you do that, you find g. So we can either call this the acceleration due to gravity, or in this case, I think it's more appropriate to call it the gravitational field, but that's not there. So either one would be appropriate. So either the acceleration due to gravity, which is listed, or the gravitational field strength of the Earth. Number 6 is a satellite is accelerated away from the Earth by the rocket, the satellite's mass. Okay, so a satellite, right, and so we're looking at the mass. What we do know is that the f of g would go down in theory, because as you get further away from the Earth's center, the value of the gravitational field is less and less and less, so the weight of the satellite would become less and less and less. But the mass is a collection, it's a measurement of how much protons, neutrons, and electrons a quantity has. And that amount is not going to change. And the general takeaway from this is that mass will stay the same no matter where you are in the universe, whereas your weight will change from location to location to location. All right, number 7, on the surface of planet X, the acceleration due to gravity is 16 meters per second squared. That should say per second squared. What is the weight of a 6 kilogram object located on the surface of planet X? So we're just doing the f of g equals mg, and we're going to take the 6 and multiply it by the 16. And so if you multiply those two values together, you get a value of 96 newtons. A 1 kilogram object is at rest on a horizontal tabletop. The force the tabletop exerts on the object is. So what it's basically asking for is what is the normal force? And so we know that the normal force on this is equal to the force of gravity, and that is 1 kilogram times 9.81 newtons per kilogram. So we get 9.8 newtons. Last two here, we have the motion of an object moving with balanced forces. So we know that if they have balanced forces, what that means is the F net is 0. That means the A is 0, which means it's either not moving or moving with a constant velocity. Running out of room there. So we just have to look at, okay, which one of these shows an object either not moving or moving with a constant velocity. And so the only one that shows a constant velocity is choice 1. And then the last one, if the sum of all forces acting on a car is 0, then the speed of the car is always remaining the same. If the F net is 0, then the A is 0, meaning it's not getting faster, slower. And it's asking for speed, not velocity, because if it said the velocity of the object, remember that turning is also an acceleration, which would mean you would have to have an F net not equal to 0. But since it's asking for the magnitude of the scalar speed, that value must stay the same if the sum of the forces acting on the car is 0. Okay, so those last few, I kind of went through those pretty quickly, but if you have any further questions, we can address them in the review class in the next few days. All right, so thanks for listening. Have a good night, and we will see you soon. Bye.